Okay. So mass we are already clear. SI unit of mass is kg. Mass is the actual content of matter in a body. Mass remains constant throughout the universe, whether you move from here to there. And I'll give you an example of that mango. You take the mango from wherever. Then we spoke a little bit about gravity and gravitation. We said gravitation is a universal phenomenon. And there's a gravitational pull. Every body attracts every other body. And when you bring that discussion from universe bodies to only Earth and the body, we'll replace the word gravitation and we will talk more in terms of gravity. So let's understand once again. Let's say this is your planet Earth and this is any object which is above the surface of the Earth, right? This is planet Earth and this is any object which is above the surface of the Earth. Earth always pulls this body towards its center. And this is known as the force of gravity. Force of gravity. Okay. For 1 minute, bacha, take out the concept of earth and body. Just go back to gravitation. Every body attracts every other body. This small body is also attracting the earth. Both the forces are same, but the movement will be seen in the smaller body because its mass is less. Let me give you a small example. I have a magnet and a needle or a nail. The magnet is quite heavy. What will you observe? You will observe always the nail to move towards the magnet. You won't expect the magnet to move, okay? But if I keep the same magnet and I keep a very heavy magnetic substance, like a big screw or a big nut opened from a truck, then what will happen? The magnet will go in. So it depends upon jiska mass hai. Samajh mein aa raha hai na? So every body attracts every other body. The same concept when you bring it for a planet, then we call it the force of gravity. Similar scenario will also be there when we are at moon and we have the same body. Right? This is say the body B. The same body is now above the surface of the moon. This will also be pulled by the moon. Obviously, moon's mass is more. Here we will call force of gravity of Earth. Here we will call force of gravity of moon. Is this understood? Right? So let's call this as force of gravity FGM and let's call this as FGE. Our first query should be, sir, does the moon and the earth attract the same body with the equal amount of force? Well, no. Well, no. The moon attracts it much weaker. It's around 1/6. Roughly, if you ask me, the moon's attraction is almost 1/6 the attraction of the earth, which means this body will fall very slowly on the moon, whereas it will fall much more faster on earth. Agreed. That means, think like students of science. That means I have a force and I'm trying to now quantify what does this force depend upon. Obviously, the mass plays a role. The mass plays a role. But in both the cases, the mass is same. So it is not mass. It must be something more than mass, which is more on earth as compared to moon. ये logic समझ में आ रहा है कि नहीं? That is because once you rotate, there is always have you ever sat on a merry-go-round in a gaon ka mela and you rotate very fast? Don't you feel like you will get out? That's it. You take if you go to Indian restaurants, then you don't buy say dal tarka. Many serve you in like a copper sort of a bucket, stylish bucket. You take that dal tarka bucket and you just move it in great speed. Not a single piece of dal will spill because the dal wants to get out. That is called centrifugal force. So there will be a centrifugal force also and forces. Both balance each other, so it's moving. Understood? So my question is not that. My question is Earth is also pulling, Moon is also pulling. We know one thing, that Moon pulls slower. Earth pulls much more faster. Now this force, we are trying to quantify. We are trying to find a formula for this force. Obviously, the force will be dependent upon the mass of the body. Mass here and mass here is same. So mass is not playing that magic. Something else is playing that magic. That something else, nahi betu. That something else is denoted by a quantity called G. ये आपको 8 में नहीं पढ़ाएगा. This was in 9, but in 9 they have now removed it. This G is known as acceleration due to gravity. Every celestial body has it. Acceleration, this is spelled as acceleration. Acceleration due to gravity. Every celestial body has it. Every celestial body. Earth has, Moon has, Jupiter has. But everyone has it in different value. The value of G for Earth is 9.8, roughly 9.81. So take it 9.8 meter per second square. Don't bang your head out here. It is around 9.8 meter per second square for Earth. And in order that you are saying that the force is less, so let me just check it. It should be 9.8 divided by 6 on 1 point. Sorry, it should be 9.8. That's a scientific calculator, but yeah, it's 1.6. Okay, it's 1.6. So if you see the G for Moon, this is 1.6 meter per second square. Now see the difference. Now you will get the beauty of it. Let's say this is a 2 kg mass. When we took it to Moon, what is the mass? 2 kg. No change. If you see the Moon's gravitational force, then the Moon's gravitational force will be 2 multiplied with 1.6. Got it? And if you look at Earth, it will be 2 multiplied with 9.8. This is force. So what should be the unit? Newton. So let's calculate how much it should be. Don't feel that these are hard stuff. Try to okay. So this value should be around how much? 9, 9, 18, 18, 8, 16, 19.6 Newton. Earth is pulling the same body with 19.6 Newton, whereas Moon is pulling the same body with 3.2 Newton. अब आपको थोड़ा सा मजा समझ में आ रहा है? Are you understanding this? Right? And what is new? How in grade 9 you will learn how do you get Newton? Newton is arrived when mass kg multiplies with meter per second square. This was meter per second square, kg is. Right? So Earth is pulling with how much? 19.6. Moon is pulling with 3.2. Itna samajh mein aaya. What did you understand? Every celestial body pulls every body towards its center. That force will differ for every celestial body. That force differs not because that the mass changes. The mass is same. It differs because every planet has something called a acceleration due to gravity. And this value is different for different planets. Do you understand? With this concept, now we bring our concept of weight. Weight. Okay, what is weight? Weight is a force with which, try and absorb first, then you write, with which Earth pulls any body to its center or towards its center. Now use your common sense. What is weight? A force with which Earth pulls any body to its center. Can I not call this now as weight? Yes, that is weight. This is the force. And why are you so specific about Earth? Rather, we can say any celestial body. Any celestial body. But in that case, we will say, if you are doing it on Earth, we will say, what is your weight on Earth? And if we go to Moon, we just can't say weight. We will say, what is your weight on Moon? What is weight? Weight is the force with which a body is attracted towards the center. This force differs. But when we talk about mass, we will never question what is your mass on Moon. What is your mass? Your mass is same whether you are on Moon or anywhere. A concept समझ में आ रहा है? Weight will change, and the fellow who is responsible for changing weight is something called acceleration due to gravity. This value changes for different planets. इतना समझ में आया? And why did I call this force is, this is weight on Moon. समझ में आ रहा है? And this is weight on Earth. Can I change the slide? I will revise it, don't worry. So now one concept has come to us, weight. Weight is a force, and this force is given by the mass that you are trying to, whose weight you want to measure, multiplied by the acceleration due to gravity. In short, we say that weight W is a force which is mass multiplied by G, and this will be in Newton. Agreed? This weight can be measured. Now our weight can be measured on Earth. If it is Earth's weight, then we will write mass into G, G of the Earth. If you want to measure weight on Moon, then it will be mass into G of Moon. If you want to measure the weight on, say, Mars, then it will be mass into G of Mars. By now, one thing has entered your head, that once you change the planet or the celestial body, the weight starts changing. Agreed? The first concept. So when we define weight, we will say weight is the force with which a body is attracted towards its center by Earth. You can ask me, sir, why are you so hell-bent for Earth? Are, who is going to go to Moon and measure a mango? We will be living on Earth only, right? So let's concentrate on Earth. But if you even say that the weight of a body on any celestial, the weight of a body as measured on any celestial body is the force of gravity with which that celestial body is attracting the body. So this is very generic. So the weight of a body on Earth is said to be the force by which Earth is attracting the body towards its center. And since weight is a force, it is given by the product of mass and acceleration due to gravity. Mass never changes. So if you encounter different weights in different planets, it is all because of ये G पलटी मारता है. समझ में? हाँ. Acceleration due to gravity. इसका नाम बहुत बड़ा है. Like in that movie was there na, my name is very small. Iyer. Srinivas Venugopal Iyer. Very big name. Acceleration due to gravity. और अर्थ के लिए इसकी वैल्यू कितनी है? Since we are on Earth, the value on Earth is 9.8 meters per second square. समझ में आया? 11 में. और अब देखते हैं गड़बड़ कहां पे हो रहा है. That means one thing is understood now. One thing is understood that if I have a mango whose mass is say 1 kg, does the mass change? I take it to anywhere? Not at all. And we are doing everything now with respect to say Earth. Understood? So mass is 1 kg. How much should be the weight of the mango? 9.8 Newton. Mass multiplied by 9.8. ये समझ में आ गई नहीं calculation? Did you understand this? Weight is what? The mass 1 kg multiplied by 9.8 Newton. Right? So question arises. Now a lot of things will come in your head. Sir, हम टमाटर खरीदते हैं, kg में खरीदते हैं. वही जो अर्णव को पूछा था, वो सब भी अभी आंसर करना है. Is this understood? Now in your book they say weight is measured by an instrument like something like spring balance. So let us look at a spring balance. खुद ही बना लेते हैं. एक spring balance बना लो. Spring balance, right? A spring balance will what happen? A spring balance will have a graduated scale out here. There will be a graduated scale. There will be a graduated scale, something like this, right? And inside you will have a spring, all right? As a spring रहेगा. And on this spring, an S hook will be there on which you are actually putting your item. Got it? Now let's look how the spring balance. Now there are some stylish spring balance which can on one side read mass and on one side read weight. What do? You hang it on something and then you put your potato or whatever it is. Earth is going to attract, the spring is going to elongate, right? The spring is internally connected to one pointer. There will be one red color pointer out here, red color pointer, and the pointer is actually connected to the spring. More is the weight, the red color pointer slides down. समझ में आया ना? The red color pointer, something like, let's say you have a red color pointer which is like this, and this pointer, children, is actually connected to from the back side on the spring. So when you are actually pulling it down, the pointer slides down. And here what we will do, we will have various measurements. Sorry. Okay, we'll have 1 minute. and we will, this is on the back side, okay? So we will have various measurements out here. So let's say this is one measurement, right? And similarly, there will be 1, 2, 3. There will be 1, 1, 2, 3, 4, 5, another 1, 1, 2, 3, 4, 5, another 1, like this. Suppose the graduations are there, okay? And out here, I have started to give, say this one is 1 Newton. This one is, or say, if you want to do it in mass ways, so weight will be measured in Newton, mass will be measured in kg, okay? And this is 1, so this is 1. So this is, say, 1 kg. So on this side, how much it should read? 9.8 Newton. Anything which is 1 kg, its weight should be 9.8 Newton. Okay, if you are 2 kg, then how much it should be? 19.6 Newton. Capacities will be there. Obviously, you can't weigh an elephant out here. Some spring balances will be like 5 kg, which you use it for your home purpose. Some spring balances will be like 17, 18. Spring balances are not that very good because the spring ultimately elongates. Iska life बहुत कम होता है. Nowadays, everything is digital, okay? So, let's say if you are measuring 3 kg mass, 3 kg, how much it should be? Tell me. Multiplied by 3, 3824, 2 carry over, 3927 plus 2, 29.4 Newton. Have you understood this spring balance now? So tomorrow, if you exactly take a 1 kg mass, 1 kg mass means like the vegetable seller has that 1 kg, and you hang it, and there will be something here also at the start. Let's say this is 0 Newton and this is 0 kg. Right? Initially, my marker will be here. As soon as I put a 1 kg, it will slide down. And should slide down and hold where? At 9.8 Newton. Then you can, somebody asks you, what is the mass? 1 kg. What is the weight? 9.8 Newton. We have still to answer our vegetable because we have never used this word called Newton when we go and buy mutton. How do you buy it? 1 kg mutton, 1 kg chicken, 1 kg. We have never bought something in the name of Newton. अब उसको भी एड्रेस करना है. पहले तो किताब का एड्रेस कर लेते हैं. तो आइए फिर से देखते हैं. Weight is a force with which every object is pulled towards the center of the earth. Weight is given by the product of mass and acceleration due to gravity. Weight differs from place to place. Even on earth, though we take 9.8 as standard, everywhere it is not 9.8. It differs in poles and equators. You should study in higher classes. In equators and poles, the value of G also fluctuates. That means on the same planet itself, the weight will also fluctuate. Are you getting it? Then, why does weight differ from place to place? Because of this culprit factor, acceleration due to gravity. If the acceleration, have you heard that if you can jump 1 meter on earth, you can jump 6 meters on moon? That means moon doesn't pull you that way. What is jumping? Jumping means your ability to get released from earth's pull. Earth is pulling me right now. That's why I'm on the ground. If earth doesn't pull me, then I'm like the astronaut. I'll jump like a hydra and go. So in moon, they say that you can jump how much? 6 meters. That's why I divided it by 6. Moon's gravity is 1/6 of that of earth. So anything, if you are weighing 6 kg, not 6 kg, 6 Newton. If you weigh 6 Newton on earth, how much will you weigh on moon? 1 Newton. All of us will become very nice. The person who is 60 Newtons will weigh how much? 10 Newtons. Because it's 1/6. Itna samajh mein aa gaya. Right? Now we have to answer, then sir, why are we buying potatoes with 1 kg and all? That concept we have to study. Ye samajh mein aa gaya. So now let's say, what is mass? Let's do a last definition. Mass, the content of matter in a body. Weight, the force with which a body is pulled by earth towards its center. Unit of mass, kg. Unit of weight, Newton. Mass is universally constant. Weight varies from place to place. Mass is a scalar quantity. Weight will be a vector quantity because weight is a force. लिख लें जरा इस चीज को. आइए इस चीज को लिख लेते हैं. Then that is very common. So we say, let's distinguish between mass and weight. अब ना हम सीखेंगे. और उसके बाद अर्नब का आंसर करना है ना, हॉस्पिटल ने क्यों उसको न्यूटन नहीं लिखा. लेकिन हॉस्पिटल गलत है. That I'll tell you. Number 1. mass is content of matter in a body. बच्चा एनी डाउट एनी लाइन यू कैन टेल मी. नंबर 2 यहाँ पे क्या लिखेंगे? ओहो सॉरी, नॉट नंबर 2. अच्छा, व्हेन यू से डिस्टिंग्विश बिटवीन, देयर शुड बी एक्चुअली कंट्रास्टिंग स्टेटमेंट्स दैट यू राइट. यू जस्ट कांट राइट आई लव नूडल्स, ओह ही इज वेरी सैड इन द मॉर्निंग. ऐसा नहीं है. ही डजंट लव नूडल्स, वैसा होना है पूरा. तो यहाँ पे हम क्या लिखेंगे? फोर्स बाय विच अर्थ pulls a body to its center or towards its center is the better English. Okay, towards its center. इसे हम force of gravity भी बोल सकते हैं. Force of gravity भी बोल सकते. That means one thing that is understood while mass talks about matter, weight talks about force. ठीक है बाबू? Number 2, SI unit kg. Number 2, SI unit Newton. Number 3, constant universally. Yes.
But the first one you say that force by which Earth pulls the body.
Yeah.
Can't it be any celestial body?
Any celestial body, then it is weight on that body. When you book a ticket to that, please include me. We will go there and do. That is very theoretical statement. Do we measure alu in moon? Sorry, yeah. Right, very good. You're coming for class here, right? So if you say, what is the timings of the class in the Oxford University? How does it matter to you? You're going to come and see my face only. And I'm going to tell you, cut your hair and come. Otherwise, next class, no entry. Right? Yeah. He understands. Only that he has to be told in his lingo. Third, varies from place to place. Acha, at grade 8 level, this much is sufficient. But my bachas are not grade 8. They are grade 9. Because we will write here. Weight is a force which is equal to mass into एक्सीलरेशन ड्यू टू ग्रेविटी. हमें ये जानना चाहिए कि क्यों वैरी करता है. while mass is constant, this fellow varies. और भाई साहब अर्नब समझ में आ रहा है तो अभी, है ना? अब देखो, अब खुद ही कंपेयर करो. जो ज्ञान तुम्हें पहले पता था, तुम्हें कितना कुछ नया पता चला अभी. why weight varies हमें पता नहीं था. weight varies because mass is constant. ये चेंज होते रहता है. Right? It is like the same computer bought in different countries, different price. Okay, next, last 4. This is a scalar quantity. And what about this? This is a vector quantity. Why is it a vector? Anybody can tell me why it is a vector? Because it is a force. And force always has a direction. And a magnitude. Yes. Earth pulls a body by 2 Newton. Where? Towards my house or what? No. Towards the center. डायरेक्शन इज वेरी इंपॉर्टेंट. हो गया? समझ में आ गया? चलें अभी, ज्यादा टाइम नहीं, हमको स्क्वायर रूट के डाउट्स भी क्लियर करने हैं. हो गया कि नहीं? हाउ कैन यू ऑल बी सो स्लो? अरे निवेदिता कैसे हो बिट्टू? निवेदिता तो अभी, निवेदिता पिलो यूज नहीं कर रही है ना सोने के लिए. सिर्फ आर एस अग्रवाल है. बहुत आर एस, एक आर एस आज लेने ही गए हैं. बाजार में भर के आर एस अग्रवाल है. हाँ, तुम्हें भी जाना चाहिए था वो बाजार देखने, तभी ना मुझे. यू शुड गो. जनरली your children always get new books every year, new pencil box and all. You should always go to these shops. And then वो ज्योमेट्री बॉक्स एंड ऑल देते हैं ना उसको. आपको जाना चाहिए सेकेंड हैंड बुक मार्केट, जहां सेम आर एस अग्रवाल, आर डी शर्मा, पुराने वाले मिलेंगे आपको हाफ प्राइस. वेरी गुड. Shall we go ahead? Shall we? Okay. Now, our next concept. Okay. Now, the real life problem, though this is not in your book. Okay. Now, every garbar is happening because of the unit system. Unit system. Before this, we should understand one thing. So far, we have understood if you are a body of 1 kg mass, then how much is your weight, beta? 9.8 Newton, right? And when you talk this statement, you're talking this statement because you are a modern guy who believes in SI system of units. When SI system of unit was not there, we had a system of unit called the metric system or the MKS system, meter kilogram second. MKS में this concept, like what do we say? Weight. Weight is a force which is mass into gravity, acceleration due to gravity. This is the exact definition. MKS ने एक problem कर दिया था. MKS went by the concept that according to them, the unit of mass is something called kg, which is same in SI. अगर हम SI में देखें, so SI में mass का लिखा ही हुआ है ना. SI में what is the unit of mass? kg. No issues. MKS has a weird unit for force. This unit is known as kg force, written as kgf. हाँ, kgf. kg force. इसको हम क्या बोलते हैं? kg force. In many pressure gauges, still you will find kgf.
kg force को
किलोग्राम force भी बोल सकते हैं. That's kg force. ये nowadays we don't use it, but still I passed my engineering from 95 to 99. So we used to be rugged a lot. I mean, we'll be given problems in this, we'll be asked to give the answer in this. So your conversions should be very good. आजकल सब लोग SI में ही पढ़ते हैं. हमारे टाइम पे this was very very prevalent, right? Like if you okay, you're in grade 8, you don't right now don't know. Okay, kg force. Now see here. Here we say 1 kg mass weighs how much? 9.8 Newton. In MKS, the concept that they said, उसमें G का concept नहीं है. They say a 1 kg mass weighs 1 kg force. Are you understanding? They, as per that, and that is how you are supposed to study. 1 kg mass is supposed to weigh how much? 9.8 newtons. No question about it. This is correct. This is also correct as per their standards. They say 1 kg mass has a force of how much? Has a weight of how much? 1 kg force. Here is where the difference starts. Now let's say you have a 2 kg mass out here. A 2 kg mass will have a weight of how much? 19.6 Newton in SI system. However, here a 2 kg mass will weigh how much? Can you tell me? How much should it weigh?
2 kg.
2 kg force. 2 kg force. Have you understood? 1 kg mass, this is the concept it has taken. There is no G. The concept of G is not here. The concept of G is there. Understood? So if you want to marry these two systems, if you want to marry MKS and you want to interchange it with SI and you want to compare a quantity called force or weight, then how will you compare? You will say 1 kg force is 9.8 Newton. This is the conversion. 1 kg. क्या हो गया उजैर घड़ी छोड़ दो 1 kg mass is 1 kg force, 1 kg mass is 9.8. So if you combine both, if you are talking MKS, it's like 100 paisas make 1 rupee. If you are talking MKS, it's 1 kg force. If you are talking SI, then it is 1 Newton. No, 9.8 Newton. And if you want to make it 1 Newton, then this becomes 1 by 9.8. समझ में आ रहा है? हाँ, इसको अगर 1 करोगे तो हम क्या कर रहे हो? इसको डिवाइड करो 9.8, इसको भी डिवाइड करो. This is the conversion for MKS to SI. Now what happens? Although we are studying everything in that same concept as I told you, if you go to the shopkeeper hardware store and you say 25 ka nail dijiye, he will treat you as a fool. But you are correct because he sells everything in inches. The British ruled us. So the British introduced a system called FPS, where everything is in foot length, weight is in pound, time is in second. Cake still there we say, kitne pound ka cake aaya tha? If you go to Hong Kong, was ruled by British, you will see every vegetable market having a scale where the weight is not in kg, everything is in pound. If you go to US, it's ounce. So different geographies go. That's why SI was created, so that the world should follow one. British has introduced this FPS in us. All your flats where you stay have been sold to you in a sale document. That's a legal document. That document will follow SI. They will write how many meters square is your house. But when you talk, what do you say? हमारा ना 1 series का flat है 1700 SFT. What is SFT? Square foot. अंग्रेज होना, गुलाम होना तो वो फुट ही आता है आपके मुंह से. Carpenters will go on saying inches. Carpenter does not knows. If you tell a carpenter आप ना इसको 183 centimeters बनाइए, क्या बोल रहे हो साहब? अरे 24 बना दे, 24 इंच बना दे. But he'll make it perfect. Let's talk in inches. Similarly, the world still follows MKS in commercial norms. Are you understanding? So, here is a person and his mass is how much? Say 20 kg. This is his mass. And he goes to a hospital and now fills up the hospital's health card. And there will be something written as weight. How are you filling the weight? You are writing 20 kg. यहीं पे गड़बड़ है. आपको क्या लिखना चाहिए था? 20 kg F. Just because you are not writing that F, the whole confusion is coming up. How much tomatoes did you buy? I bought 1 kg mass of tomatoes that weighed 1 kg force. If I would have put a change, suppose it was a digital scale, and if I would have changed it to SI, immediately the reading will come what? 9.8 newtons. So this boy, 20 kg, right? For 2 kg, how many newtons? 19.6. So he will read as 196 Newton. But so much is our comfort factor. If you suddenly, Uzair today goes and says to a sports club, tell me, boy, how much you weigh? And he says much more younger. He's in grade 2 or 3. I weigh 196 Newton. Those numbers are not familiar with us because we know बच्चा है 20 किलो होना चाहिए उसका. 20 किलो force. ये kgf नहीं लिखते हैं. And not forget about illiterate people. Like qualified engineers don't write it. And that's what I used to say when I go in interviews. I ask these only. You should know what it is. 1 kg force. If you write kg, then the hospital chart is not giving your weight. It is giving mass. Kg. Because mass is kg in MKS also, mass is kg in SI also. kg से weight नहीं होता है. अगर आपको weight measure करना है, then you say, in what unit do you want? I want it in MKS unit. Okay, your child is now 40 kg, so his weight is 40 kg force. Earth is pulling him with a force of 40 kg force towards the center. 40 kg force. The unit's name is kg force. Kg force. Kg force means a unit of force. Kg means a unit of mass. It sounds weird. That's why people are not writing that F. But you should write. And I told you the other day that you should go and see once you open your car, every time, did I tell you or grade 9 people? Yes, you all only. You all didn't see. Whenever you open your car door, driver door, with the lock, there will be the pressure. There will be pressure readings. You will see one reading as kg force per cm square. Kg. They will write F properly because that's a car manufacturer. He will not do mistake. Whereas we do what? PSI. ये जो आप पेट्रोल पंप में जाके बोलते हो ना 36 कर दो. 36, read the unit. PSI, pound per square inch. Because British. गुलामी है हमारे अंदर. Actually, pressure's unit should be Pascal, Newton per meter square. But if you go to the shop and tell him, जरा इसको ना 280 Pascal में कर दीजिए. Rohan, next time Nani's cylinder is there, right? In that cylinder, there will be a humidifier. You just go and check the pressure. There they will write Pascal, Newton per meter square, kgf per cm square, everything they will write. Pascal is a unit of pressure. बाद में पढ़ेंगे, हम भी पढ़ेंगे उसको. Have you understood? यही घपला है. So when you are buying at Ratnadeep 2 kg, how much mass did you buy? 2 kg. How much was the weight of it? Then you ask, sir, in what unit do you want? I want in SI unit. Then, sir, it is 19.6 Newton. I want it in MKS. Then it is 2 kg force. Then it is 2 kg force. That's why How do you measure weight? By putting it on that tarazu and everything is pulled towards the center of the earth. So today we brought a very big fish, 5 kilo. 5 kilo is the mass of the fish. How much did the fish weigh? 5 kg force in MKS. And if you want to convert it in terms of, say, what do you call SI, then it is roughly 50 newtons. This 9.8, ये जो 9.8 हम बोलते हैं ना, this is roughly taken as 10 newtons. Calculation becomes easy. Calculation becomes easy. ठीक है? So 10 kilo Ashirwad atta packet. What is the mass of atta in it?
100.
What is the mass of atta in it? सुनिए पहले. 10 kg. Whether you are saying by MKS, whether you are saying by SI. How much should it weigh? 100 newtons. As per this, 10 kg force as per this. आप बता अर्नब, क्लियर हुआ? तो हॉस्पिटल वाले जो गलती करते हैं उन्हें ये F लिखना चाहिए, नहीं तो वो तुम्हारी वेट नहीं देख रहे हैं. बिकॉज वेट का यूनिट कैन नॉट बी केजी. वेट का यूनिट इज आइदर पाउंड इफ यू आर ब्रिटिश का गुलाम, SI न्यूटन, और यू आर KGF. It cannot be kg. Kg can only be the unit of mass. यही चीज किताब में इतना था, हमने 2 क्लास लगाया, लेकिन एंड में गधे की तरह नहीं निकलेंगे. समझे हैं अभी चीज को? समझ में आया? Any questions so far? If not, you can, I will just do some, this part is over. Spring balance you understood? Okay, in spring balance I did not cover one thing. Where is my beautiful spring balance? Okay, sometimes they will ask you that between this how many divisions we have? We have 5 divisions, है ना? So here also we have how many? 5 divisions. So each division should be how much? 0.2 kg. 5 divisions give you 1 kg. So each division is 0.2 kg. 0.2, 0.4, 0.6, 0.8. Again the next one. So if somebody asks you, what is the minimum accurate mass you can measure with this spring balance? 0.2 kg. Accurately. And that's why we have moved to the world of digital scales. ये सब में पता नहीं चलता है ना. आलू एंड प्याज थोड़ा ऐसा वैसा होगा, people don't mind. But if it is gold, गड़बड़ हो जाएगा. ठीक है ना? Any questions on mass and weight? Last. Second, metric system बोलते हैं. हाँ बोलो सर. Chapter मोटा मोटी finished है. Whether we see, if you go by the old syllabus, force and pressure was a chapter. So हमने force पढ़ लिया, pressure नहीं पढ़ा. Old syllabus में friction एक chapter है, हमने friction को भी पढ़ा. New syllabus में contact forces में friction is a part, smaller, but हमने उसको बहुत लंबा करके पकड़ा. New course में mass and weight है, old course में नहीं है. तो old वालों ने भी mass and weight पढ़ लिया. Science में कोई भी चीज जानना तो कोई गलत बात तो है ही नहीं. अब हमारी अगली topic will be pressure. Once we do pressure, we will close physics for some time. बहुत कुछ हमने पढ़ लिया, because by that time our Nivedita and all will return back. Then I have to throw the missile also. ना बहुत पढ़ लिया आपने. रहती हाँ 6-7 तो पता नहीं बेटा. न्यू बुक में देखना पड़ेगा. ओल्ड बुक में फोर्स एंड प्रेशर का क्या है. सो वी आर लर्निंग बाय टॉपिक्स, सो वी विल गो एज टॉपिक्स. ठीक है, चले इसको क्लोज करता हूं फिर. ओके चलिए, यहां पे थोड़ा सा वीडियो को रोक लेता हूं और एक नया